Welcome friends. In this video I am going to solve an example on composite function of a partial differentiation. Here u equal to f of x by z and comma y by z. U is a function of x, y and z, but f is a function of only two variables, x by z and y by z. This one I will convert it into a function of composite function type. Okay, let me put x by z equal to, say for example, x by z equal to r and y by z equal to s. Then given function u is equal to, I can write it as f of r comma s, and r is a function of, okay, x, y, z I will take, and as I know this z is not there, sorry, y is not there, but it is a function of three variables I will consider, and I can write it as x by z, and s is equal to is also a function of x, y, z. Anyhow, x is not present here, but anyhow I will take it as a function of three variables. Okay, now here u is a function of r and s, and r and s are the functions of x, y, z, three variables. Therefore indirectly u is a function of three variables, x, y, z. Therefore there exist three partial derivatives of u with respect to x, y and z. Those are dou u by dou x, dou u by dou y and dou u by dou z. How to define and how to find out them, one by one we'll do here. First, dou u by dou x. U is a function of r and s now first. Therefore there exist dou u by dou r and dou u by dou s will exist, but I want u with respect to x. Therefore applying the chain rule, I can write into r is a function of again x, y, z, three variables. Therefore partial derivative exists as dou r by dou x, plus also s is a function of x, y, z. Therefore here also it is dou s by dou x, because partial derivative exists since s is a function of three variables. Now let me find out this dou u by dou r. U is some function f, we don't know that. Therefore dou u by dou r I will keep as it is, dou u by dou r by dou x. R with respect to x, x by z. Here 1 by z is constant and partial derivative of x is 1, plus dou u by dou s into, because I am keeping dou u by dou s as it is because of u is some function, y function we don't know, that's why dou u by dou s, and dou s by dou x, s with respect to x, no x term is there, therefore it is 0. That implies my dou u by dou x is equal to, dou u by dou x is equal to 1 by z times dou u by dou r. Correct? Call this as equation number 1. Similarly I have to find now dou u by dou y. Dou u by dou y exists because u is indirectly a function of y also. Therefore partial derivative dou u by dou y exists. To define using chain rule, I will write it directly now, dou u by dou r into dou r by dou y, plus dou u by dou s into dou s by dou y. As u is a function of r and s, dou u by dou r, dou u by dou s exist, but I want partial derivative with respect to y. R is again a function of x, y, z, therefore dou r by dou y. S is also a function of x, y, z, therefore dou s by dou y. Therefore dou u by dou r as it is, because u is some function, I don't know what is that function, that's why dou u by dou r keep as it is. Dou r by dou y, r with respect to y, no y term is there, therefore its derivative is 0. Dou u by dou s into dou s by dou y, dou s by dou y. Y is partial derivative is 1 and 1 by z is constant, therefore it is again 1 by z. In the simplified form I can write it as dou u by dou y as 1 by z times dou u by dou s I can write. Let me call this equation number 2. Dou u by dou y, dou u by dou x. Then using these two definitions I will find out dou u by dou z also. Let me write here next dou u by dou z, dou u by dou z is equal to dou u by dou r and dou u by dou s, but I want with respect to z. Therefore, it is dou r by dou z into dou s by dou z, because both r and s are the functions of z also. Therefore, I can write this. Okay. Now, here dou u by dou r as it is, because u is a function of r as it is. We don't know what is that function. That's why dou u by dou r as it is. Dou r by dou z. R is what here? R is equal to x by z. X is constant now, and I have to differentiate 1 by z. 1 by z. X is constant, and differentiation of 1 by z with respect to z is minus 1 by z square, plus dou u by dou s as it is. Dou s by dou z. S is again a function of y by z. Therefore, I can write here into y constant and minus 1 by z square. Therefore, dou u by dou z in the simplified form, I can write it as 1 by z square times minus x dou u by dou r minus y into dou u by dou s, I can write. Let me call this as equation number 3. Using all these three, I will try to prove the required result as a LHS. What is my LHS? X dou u by dou x plus y dou u by dou y plus z dou u by dou z equal to 0. Consider that. Okay. Consider x dou u by dou x plus y dou u by dou y plus z dou u by dou z is equal to x dou u by dou x. Dou u by dou x is 1 by z dou u by dou r. Therefore, it becomes x divided by z into dou u by dou r plus y dou u by dou y. Equation number 2, dou u by dou y into dou u by dou s. Correct? Y divided by z into dou u by dou s plus z into dou u by dou z. Z into this. Correct? Z divided by z square. Z divided by z square into minus x dou u by dou r minus y dou u by dou s. Simplifying this one, x divided by z dou u by dou r plus y divided by z dou u by dou s minus this one of the z will cancel, 1 by z will multiply inside, minus x by z dou u by dou r minus y by z dou u by dou s. X by z dou u by dou r minus and plus y by z dou u by dou y cancels, equal to 0. What I have to prove this one. Okay. Like this, some more examples on this composite function I am going to do in my next videos. If you not yet subscribed my channel, please subscribe my channel. Don't forget to hit the bell icon so that you'll get the notifications of my next videos. Like this video, comment, and also share this video. Thank you, friends.